Hi, this is Math Globe. Assuming there is no gravity and friction, what is the length of ball's path in one cycle? Let the solution come. Okay, first, let's rearrange main cube here and take a closer look to 27 hollow identical subcubes. And then let's assume the ball to be an idealized elastic particle, taking straight paths in zero gravity, and bouncing off the faces in the usual manner, with equal angles of incidence and reflection on a plane perpendicular to the face. And also as seen, the ball must touch each face only once, and reflect 5 times during the cycle. Next, let's now continue our analysis further, assuming that there is no reflection. This time path will be straightforward as shown. Now if we take a closer look at these cubes, we notice that lines in figure trace the parallel paths returning the same points. Now if we shift one of the parallel line as follows, this will be equal to the length of the ball's path. Next we draw the shown perpendiculars. Then we notice that the length of the perpendicular lines will be equal to 6 units. Therefore from Pythagoras' theorem, the hypotenuses of colored right triangle will be 6 square root of 2. Likewise, the length of the last part, from Pythagoras' theorem, will equal to 6 square root of 3. And this will be ball path's total lengths in one cycle. So this is the solution.